Anyway, our next guest is actually from Ireland. No mistaking the accent when you hear him. I was thinking as an improv person, maybe we could tell an Irish joke, Willie? No? An Irishman walks into a bar and, no, just, anyway. His name's Ronan Connolly. And he earned his Bachelor of Science in Chemistry from the University of College in Dublin. He got a PhD in computation chemistry in 2003 and a PhD, and actually won a BOCS award for the best doctoral research. He's worked in areas of sustainable aquaculture, wastewater treatment, energy efficient building design. He runs a global warming blog, I think it's called Global Warming Solved, and has contributed to numerous peer-reviewed publications. Little known fact about him, he also plays guitar and you dance, right?
Yeah, that's okay.
So he can maybe do an Irish jig for you too. All right, without any further ado, Ronan Connolly.
Hi, I'm not sure how many of you caught this interesting, oh wait, do I press?
Yeah, green.
Where do I point it, here?
No, point it. Green.
This one?
Hello.
No. I don't know, it's not moving.
Right.
Okay. So I don't know if you managed to catch this interesting admission from the UN's Undersecretary for Global Communications in 2022. So let's have a listen.
For example,
can you hear?
If you Google climate change, you will, at the top of your search, you will get all kinds of UN resources. We started this partnership when we were shocked to see that when we Googled climate change, we were getting incredibly distorted information right at the top. So we're becoming much more proactive. We own the science, and we think that the world, should know it. And
wow, so I didn't know anybody could own the science. How exactly did they buy it? Or, well, let's have a look at this talk. So let's start off with the science that they owned in 1989. And this was the director of the UN Environment Programme was warning us that entire nations could be wiped off the face of the earth by rising sea levels if the global warming trend is not reversed by the year 2000. A little bit late, it seems. Okay. So just to give because I'm talking about the UN, but I'm just looking specifically at the climate change aspects. So there is different divisions in it, and the annual UN conference meetings are kind of under this branch. But what we're going to focus here is on the UNEP. They co-founded in 1988 the Intergovernmental Panel on Climate Change, or the IPCC. And so when you hear the UN climate change reports, that's what they're talking about. So let's start with the first assessment report in 1990. And I have to admit, and you can download all of these from the UN website as well. So, but I have to admit, this one is actually quite reasonable report. Even now, it's a decent report. And the key bit is they got it so that you can read it. You don't need to be a super specialist to try and follow it. So it had not too much jargon. And so they invited scientists from all sides to give their perspectives. And so it was like quite a relatively objective, but that was the problem. Because when you include all of the sides, then you get this thing. So what they focused in on is they said, well, look, the climate models say that humans should have caused about 0.5 degrees Celsius of global warming since the 19th century. And they said, and there has been about that much. And so they said it's broadly consistent with the climate models. But then because they had to present both sides, they also kind of were conceding, well, look, the 19th century was the end of the Little Ice Age, relatively cool period. And then they also pointed out the problem was that you had that warming mostly occurred in the early 20th century when CO2 was low. And then when you got up to the 1940s to the 70s, you actually had global cooling. So when the CO2 is supposed to be rising, it's cooling. And when it was the opposite of what they said. So The UN weren't very happy with that, so 5 years later they said, can you do a better job? Do it again. And so they said, right, okay, we'll do it. The problem was, by the time they'd written most of the report, the results were still the same because the science hadn't changed that much. But fortunately for them, one of the authors, Dr. Ben Santer, he said, guys, I have 2 papers. They're not published yet, but I'm hoping that they will be published sometime soon. And I think these have provided the smoking gun, the fingerprint of human activity on climate change. And so on that basis, they added into the summary for policymakers, they added in this line here, the balance of evidence suggests a discernible human influence on global climate. Okay, discernible. Wow, so what were these 2 reports? Well, the first one, it's paper 1, it's not actually proof of anything. What they did is, remember saying there was the 1940s and 70s was cooling, which is the opposite of what you'd expect. Well, it said maybe that human-caused air pollution might be contributing to cooling, and so maybe there's another explanation, and so it hasn't been debunked by the temperature trends, but that's not a proof. But this was the big one. They said, oh, what we've done is we've run a computer model, and what we've done is we've predicted what the changes in the global temperatures in the atmosphere should be with increasing CO2. And this is a complicated thing, but just this is from their paper. That's the lower atmosphere, the troposphere. That's the upper atmosphere, the stratosphere. And that's the North Pole, South Pole in between. And each of the colours, the redder it is, the hotter, the more warmer you're getting. And they're saying, actually, you get these green cooling in the stratosphere. And they said, that's what our model said should have happened. And he said, between 1963 and 1988, this is what the weather balloons were showing. And they said, oh, look, the colours are kind of similar. That's their fingerprint. Okay, that's what they were saying. And then it's like, just have a note of this little one here, because Pat Michaels and Knappenberger, they pointed out that, yes, let's just look at this, the brightest red patch on their fingerprint. And he said, yeah, if you look from 1963 to 1988, it is warming. But if you looked from a longer period, from 1958 to 1995, it's the change to sign, not going up. That meant that big red blotch should have been a big green blotch. So it wasn't just Michaels and Knappenberger. We had a number of others, including Fred Singer, who was mentioned earlier on. And so this is the science they owned in 95, and the problem was that shortly after the publication, Dr. Santer's smoking gun went up in a puff of smoke. So the 2001 report, they said, oh, okay, the problem is now Santer's fingerprints have gotten a bit too muddy, so they needed something else. But fortunately, they had another co-author, new one, Dr. Michael Mann, and he said, I have this paper, it was published, and it uses tree rings and ice core, other temperature proxies, and it shows that 1998 was the hottest year in 1,000 years. On that basis, they said, oh, it's likely human-caused. Okay. So this is a graph, a lot of you may be familiar with it, but you can see the idea is that it's like slight cooling for the first 1,000 years, and then around 1900, it rises up like the blade of an ice hockey stick. Do you see the comparison? Okay, so what happened after this report? Well, people started pointing out, a lot of people started publishing major flaws in the hockey stick, and including Willie contributed to this, but it's not just people like Willie who think that it's natural. We even had like the godfather of global warming, Wally Brucker, Hans von Storch. A load of people were all pointing out serious methodological flaws in the paper. And then other groups said, let's start doing our own temperature proxy reconstructions. And so you had here, this is the red line is the hockey stick. And then this is Esper et al. And they pointed out, look, 1,000 years ago, when Craig was mentioning about the Vikings colonizing Greenland, we had the medieval warm period. And then afterwards, we had a cooling, what was called the Little Ice Age, and then we got the current warm period. Okay, so that's not a hockey stick, is it? And then we also had Moberg et al. They actually went all the way back 2,000 years. And so you can see, again, 1,000 years, medieval warm period, Little Ice Age, and the current warm period. Now, some of you might be saying, oh, but Ronan, look, you have this little green bit here. It's hotter than that. Well, okay, the green bit is instrumental records. Proxies are good for doing comparisons, but they're not the same as instrumental. And if they were, when they're doing the weather reports, they don't cut down a tree, count the number of tree rings and say, that's what the temperature is. They use thermometers. So they're good for getting relative, but they're not, it's apples and oranges to compare the two. So this is a science they owned in 2001. And again, they were relying essentially the hockey stick graph, but then pointing out problems with that, others pointing out that there was a similar medieval warm period 1,000 years ago, and all of this stuff here. So now they were stuck. They couldn't use their hockey stick anymore, so they said, well, we have a new plan. Computer models, the savior of the IPCC. So they have what are called detection and attribution studies. So it's a little bit technical, but you need to understand it. What they do is, a forecast is you make a prediction of what's going to happen in the future, right? So a hindcast is you make a prediction about what should have happened in the past. So what the computer modelers were invited, they said, look, can you simulate what should have happened in the 20th century due to increases in greenhouse gases, anthropogenic forcings is what they called it. And they said, could you also throw in some natural factors? So some of the models looked at changes in the total solar irradiance, TSI, the amount of energy reaching the Earth from the sun. And they also said, let's look at volcanic activity. And then they said, look, some of them looked at both. And that gave us this pink envelope. Now, the black line is their global temperature curve. And you can see, oh, it kind of fits in. But then they had 5 models, only 5, went and they reran it just with natural factors, and they got the blue envelope. And you see that the problem, they said, oh, but look, from about the 60s on, you don't see, there's a divergence. And said, that is their proof. They said, so therefore, from the 60s on, is mostly anthropogenic. That's their argument. But is this a good argument? Well, the first question is their models good enough? Were they including enough natural factors? And I just explained their method of volcanic activity, they are only considering one factor. If you have a volcano that erupts the dust so high up into the stratosphere, then that called a stratospheric volcano, they say that leads to 2 to 3 years of cooling. But you can't get warming from cooling. So the only way you can get natural warming is if you get a long-term increase in TSI. So that's the only mechanism, according to these models, for having long-term warming. But other researchers have been pointing out there's loads of other mechanisms. You can have indirect solar influences, changes in oceanic and atmospheric circulation, other types of volcanic activity, cloud cover changes. So it's a very simplistic definition. But the other thing is, do we know how TSI has changed? And so it's like, the thing is, we don't have direct measurements of TSI before the satellite era. So what you have to rely on are solar proxies for it. And there are ones like the carbon-14, beryllium-10 isotopes. But the one that most groups focus in on is these sunspot numbers, which go back to Galileo's time. And the thing is, this is not so... essentially what they have is every 11 years or so, you get a rise and then a fall, a rise and a fall. And in the minimum, you end up having zero sunspots. You can't get less than 0 sunspots. So it's always the same minimum every cycle, but that you get sometimes increases from one to two. And so that's what a sunspot. You see these, at the moment, we have quite a few sunspots because we're at its near solar maximum. But solar proxy just goes up and down, always the same zero. But what's actually happening to TSI? So in 1978, we had Nimbus, and then in 1980s onwards, we had NASA's Akram satellites, and we've had more since, as Willie mentioned earlier on. And so they said, oh, we can directly monitor TSI from space. Wow, we can finally see how good our sunspot proxies are. And then it turns out, oh, they're not so good. So the thing is, you do get this 11-year cycle, but there are also changes between solar minima and solar maxima that are not captured by sunspots. So that causes a big problem for the groups using sunspots as a proxy for TSI, including the IPCC. So what is the IPCC? Well, fortunately, there is another rival group led by, Froelich and Lean. They said, do you know what we can do to fix this problem? What if we take NASA Akram satellite data and we adjust it until it matches the sunspots? Wow. Round of applause for the PMOD group. That was it. Scafetta and West, 2007, they just pointed out, if you use the Akram data instead and for calibrating your solar proxies, you can explain most of the warming since 1900 in terms of natural factors. So this was the science they owned in 2007. So what did they do for the next report? Well, they're probably very concerned about that. So they just ignored it. They said, Akram, we just use PMOD, and we'll just repeat the same analysis. But this time we'll change it from it is very likely to it's extremely likely. Wow, that's a great idea. So it's essentially the same idea. You have on the left what they call natural forcings only, on the right, natural and anthropogenic, and you see the divergence and say, oh, it's mostly human caused. So this is when I came onto this scene here with my first, myself and my late father, Michael. We collaborated with Willie. This is our first paper. So we went and we said, well, first of all, why are they just using the green Wang et al. TSI reconstruction? Some of them, there's other ones that are similar, but we found there was 8 TSI, and like 4 of them were completely different character than those. So why are they only including that? And then the other thing is the urban heat island problem. We were saying, hang on a second, the urban heat island, cities are warmer than the surrounding countryside. Okay. But urban areas are only like 2 or 3% of the land, but they make up the majority of the weather stations that are used for calculating global temperatures are in areas that have become urbanized over the last century. And so the question is, how much of the global warming in the IPCC we're doing is actually local urban warming that's on a large scale? And the IPCC, based largely on Jones et al. 1990, a very simplistic paper, they've been basically saying, oh, it's probably less than 10%, and so we don't really need to do anything about it. Okay, well, we said, look, let's have a more serious look. So what we did is we took all of the stations, urban and rural, and you get this curve here, and then we said, let's remove all of the urban and just look at for the Northern Hemisphere, where we didn't have enough for the Southern Hemisphere, and this is what we get. So the first thing is, the long-term trend shows up to 38% could be urbanized. But the other thing is, note the character. This looks like just kind of a straight line going up with a few wiggles. But in the other one, it's kind of like warming up to the 1940s, cooling to the 70s, warming. It's almost cyclical. It's a different thing. So we said, I wonder what happens if we use one of the TSIs that the IPCC ignored and the black line. And then it's like, oh, that's an interesting result. Do you see it? Black line versus the rural temperatures. So Willie talked about this about 10 years ago at this conference. So you can check that out. But our paper was quite well received. Even we had people citing it. This guy, Professor Padman Chai, he was pointing out, oh, yeah, everyone, you should pay attention to what we're saying about TSI and the urbanization bias. So we were quite excited when we found out that he then was made co-chair for AR6, So we're like, oh, wow, maybe it'll be a nice report. So we said, okay. But as time was getting closer to AR6, we were noticing they're just ignoring the TSI. In fact, they were knuckling in it and they're digging down and they were saying, we're only going to use a new one, Mattis et al., ignore all of the others, and they no mention of urban heat island. And so we were like, okay, it's the IPCC, it's a political group, they're trying to create something. We said we want to actually see what the scientific community is doing. And for us, consensus is for textbooks. Real science depends for its progress on continual charges. And so we have to address what the different perspectives, not just the ones that, so we did this collaboration involving a large number of scientists to try. And so what did we find? Well, first off, we found when we updated and improved our urban-rural, we got the same results. In fact, it was now 39%. But we also said, well, are there other estimates of temperature records? And we said, I want you to notice, these are different ones, but notice the cooling, warming, cooling that I was talking about before, tree rings, sea surface temperatures, glacier lengths, the weather balloons, and the satellites. All of these, this seems to be a real phenomenon. And then we said, do you remember I said there was 8 TSI? We now had found 16. And we were saying, oh, a lot of them are flat. And that was the one they looked in the 5th report. And now they were saying, oh, we're going to use this one. But why are they only using the flat TSIs with the cooling or the decrease? What if they'd used any of these that were also available? They could have used them, but they didn't. And so what we found is, depending on which TSI you use and how you correct for urban heat islands, you can explain anything from global warming being mostly human-caused, as they said, or mostly natural, or somewhere in between, right? So how did they deal with that? Well, again, they completely ignored our papers. Now, look, it's not about my ego, don't really care, but just for the record, they are aware of us. They cited our paper on snow cover where we were contradicting saying that their coverage of snow cover was completely wrong, except they twisted it to make it sound like we agreed with the IPCC. That's the way they do it. So they then said, but there was a journalist for the Epoch Times, Alex Newman. He was interested in this story because our paper had been published in June 2021, and AR6 came out just a few weeks later, and they said, he asked the IPCC, did you consider this in your report? And they said, no, we didn't, because we'd missed the deadline by 11 weeks, which is true, that's fair enough. But notice the corollary. That meant the day they launched their brand spanking new AR6 report, they were saying, oh, it's already past its sell-by date, and we know, and we don't care. Okay, that's the thing. And then I just want to knuckle down on just this other point that they mentioned, which was the urbanization. They repeated the claim, but not only did they insist in saying, they said this, cheek of them, they said, no recent literature has emerged to alter the AR5 finding. No recent literature has emerged to question it. It's like, or to alter. So look at Zhang et al. 13% Scafetta, up to 40%. These were in the deadline. They had met it. But also, look at this. Xi et al. 2019. They cited this particular paper. Now, this is a large thing, so I just got to do it. But I just want to see. This is page 1 of Xi et al. Okay? And so I just want you to, let's zoom in on this little bit down here. And it's like, what does it say? AR5 said that urbanization bias is less than 10%. However, other studies have demonstrated that urbanization would have a much larger effect. Namely, Connolly and Connolly have analyzed this. So the paper that they're citing is already contradicting that statement. And it's like, look, IPCC, fine, you don't have to cite my work, but if you're going to cite a paper, can you at least please read the first page of the paper you're writing or citing? And so also remember, co-chair, he was talking about it. So Epoch Times asked, well, what happened? Why did you say that when the co-chair is saying it's an issue? He says, decisions on citations are up to the chapter team authors, not the co-chairs. So not even the co-chair input was sought on this. So this is the science that they have owned in 2021. And one other thing I wanted to point out, this is the exact same analysis since 2007, 2013. The only thing that changes is their confidence in it. It was very likely, extremely likely, and now it's unequivocal. And the literature is against it. So that is how the UN came to own the science.
We're becoming much more proactive.
Yes.
We own the science, and we think that the world, should know it. And
that's all, folks.
Okay.
That was good.